Okay, hello everyone. My name is Miroslav. After having fun with breaklets, maybe you will try, maybe you want to try to recover your instance before formatting disk. So in that case, yeah, this session might be useful. So a few words about me. So I'm in Adobe since 2011. I joined 2011 as an AEM support engineer. And from my perspective today, the best way to start AEM career. So, 2011, I joined Adobe consulting team. Before joining Adobe, I had already 6 years of experience, but never tried to analyze thread dumps. So I knew, of course, what is tech trace. I was dealing with them a lot, my favorite null pointer exception, but never was trying to analyze performance issues by looking at the thread dumps. So why to try to become more comfortable analyzing thread dumps? So by looking at the thread dumps, we can solve concurrency problems. So sometimes they are directly reported in thread dump if deadlock occurs in the system. So if we are lucky, we will open thread dump, and there will be in the report thread lock detected. Sometimes it will not be the case, but then with a bit deeper analysis, we can figure out ourselves where is the bottleneck, and we can realize that we have a problem with performance. So we can also do with thread dumps long-running thread analysis. So, and we can do as well runtime profile of our application. So yeah, many reasons why to try to master an thread dump analysis and be more comfortable with that. It will improve your root cause analysis skills, and it's also fun. So nowadays, I don't look at thread dumps every day or every week. Nowadays, it's more really for me kind of a puzzle, Sudoku that I want to solve from time to time, and that's why I'm always willing to help colleagues in Adobe whenever they have issue looking at some thread dumps. So for me personally, it was not easy. So it was a really steep learning curve, and basically I want to share my experience, how it was. Yeah, precondition to be able to successfully read thread dumps is, of course, you need to know the thread states. I already knew that before 2011. I was exposed a bit to the multi-thread programming, but actually knowing those states, and I think I even had Java certification under my belt, it didn't give me the head start. Yeah. Next thing, when you want to analyze thread dump, of course, you need to know how to take thread dump. And then I believe to many of you from AEM community, this link first link is well known. And outside of the AEM community, this link must be really well known, because it's usually the first link when you try to search Google how to take thread dump. So this article is halpixadobe.com. In this page, we have a couple of methods described how to take thread dumps. So you can check yourself. So second way, you can use the Felix console. And there are two ways to take thread dumps from the Felix console, and one way is basically producing the output same as a command JStack. I didn't try this way in situation when instance is under heavy load. I'm not sure how it will behave. Will we be able to take thread dump? So third way here I outlined, yeah, you can use the JVisual VM, also good way to do that. So now I will walk you through some typical scenarios that I was facing during my career in support. First one was the easy case. Thread dump itself was reporting the deadlock for me. So here I have like one known issue in Sling. If you go to the issue, you will see that there is a thread dump attached. And JVM can easily detect deadlocks. Typically, when in the code for synchronization purposes, we use synchronize keyword. Here I have the screenshot of the thread dump. And yeah, everything here is already reported for us. So thread dump is saying that there are 2 threads in deadlock, and also we have the snippets of the stack trace. So if your job is only to understand what is the problem currently in the instance, case closed. So you say, okay, there is deadlock. You open the Jira issue. If you have time, you can try to solve issue yourself on the code level, maybe create pull request. And yeah, that's more simple case. Maybe I had it once or twice in my life. Yeah. Things are getting a bit more complicated when in the code for synchronization purposes, Java util concurrent package is being used. So in Java util concurrent and Java util concurrent locks, there are a couple of utility classes that you can use for synchronization purposes. So we have a semaphore, we have reentrant lock, reentrant read write lock, and that one is having 2 inner classes, read lock and write lock. If you take thread dump using JStack command, always remember to use the option -L, because this option will print in the thread dump for every stack trace will print all locks owned by that thread. So we will see example later on. If you don't want to worry about that, so just start the JVM with here mentioned start option, so print concurrent locks. And then you will always see which thread is owning which lock. At least it's supposed to do that. OK, so now time for one example. Back into the future. So who remembers CQ5 share nothing clustering mechanism? Whoever tried to configure share nothing clustering mechanism? OK, not so many hands. So this feature was released 2011, so year when I joined Adobe. And that was the clustering mechanism in authoring environments between 2 or more nodes. That was a clustering mechanism implemented in the CRX, so on the repository level, and 2 instances were exchanging the content using the sockets. So during my probation period, I had fun running 2 instances in cluster mode and just debugging, like trying to figure out what's going on. So mechanism is basically the slave instance was kind of initiating synchronization. So whenever a slave instance every 5 seconds wanted to know what's happening in the master, slave instance would ping the master, and then was saying, kind of, give me whatever is new. And also, back then it was possible to have active-active clustering, so you could also update content in the slave. And then in this case, slave would again send this update to the master. So it was kind of always initiated from the slave. But whenever it was initiated from the slave, and during synchronization, master was blocked, so no read or write operations were possible. So now we will see that some threads in the master node. So here we have one thread. I'm not sure, can you see it well here? But so this is the tar PM optimization thread. So before AEM 6.0, there was already online compaction working. So that thread RPM optimization was basically doing what now we have in the AEM 6 online compaction. And you can see that this thread is blocked. So let me, yeah, maybe. So here we see that the thread is blocked, waiting for this monitor. And here, like I mentioned, the flag that is useful, if we use the -L in JStack, we will see all concurrent locks owned by that thread. But here, like this thread is owning no concurrent locks. So the question is, okay, who is owning the lock over this monitor? And in the thread dump, so there was one thread. So this thread is basically a cluster synchronization thread. So the thread is running on the master and then talking with the slave to synchronize the content. And below label locked ownable synchronizers, we find the match. So basically, this thread owns the lock and is blocking another thread. So in this concrete support case, what was the issue? How daycare was created? Basically, customer was complaining that both master and slaves are blocked. It's not possible to read or write. So yeah, of course, escalation P1 issue. What was actually the problem? The problem was that the slave instance was offline for 2 days. And then customer decided to bring slave online again after 2 days. And of course, after 2 days, a lot of content has been created on master. And then slave was trying now to synchronize. And as I mentioned before, during synchronization process in share nothing clustering, basically no read or write operations were possible. Yeah. So now I will just quickly show you the demo. One moment. I will be using my favorite tool for thread dump analysis. So actually, that's the tool that I first started to use, and I found my way around, so I continued to use it. So I will open the thread dump. So usually when I start looking at the thread dump, here on the left-hand side, so we have multiple views. So I like to start with the thread view. I like to sort them all by the state and just see, okay, what's going on, just to have the feeling of the situation. And here I see, okay, so a lot of get post requests, basically waiting for monitor entry. So, okay, so I have reason to progress further and continue looking at the thread dump. After that, so we have a few other views below, but typically I go from this view, I go into the monitors. And then what's my goal here? My goal is to find the monitor where the big number of threads are waiting for that monitor. I just scroll and just let me, for example, this one. So here we have, it's even red, yeah? So we have information that 151 thread is waiting for that monitor. I expand the tree. I can see the threads, get post request. And what's nice here is that I have even information about the thread that is locking this monitor. So I click that thread, I maybe check the stack trace, and I can see that this thread is again blocked. Okay, it's blocked waiting for another monitor. So I want to find out more about this monitor. I click on the monitor, and then I'm back into the monitor view. Here I have another monitor where, again, information is that 14 threads are waiting on that monitor. And again, what's nice in this tool, I see that the thread is being owned by, that monitor is being owned by this thread. I click that thread, and similar situation again. So this thread is again blocked on another monitor. I jump to this monitor. Just 1 second. I jump to this monitor, and here I have 2 threads being blocked and 1 thread that is owning the lock. And that's exactly the thread that you saw in my presentation before. So synchronization between the master and slave. So basically, tool was really helpful here. Yeah. So I mean, nothing to tell much more about this use case. So let's continue presentation. But, yeah, there has to be always one but. And let's check following example. This is just simple example. I'm using the main method. In this main method, I want to try to use 2 utility classes from the Java utility concurrent package. I have semaphore and I have reentrant read-write lock. Actually, I will try to acquire semaphore and I will try to acquire read lock. So so those are 2 operations. And here you have the stack trace from the thread dump. So the code in the middle, so basically I'm just trying to simulate some useful work, yeah? If you look at the stack trace, you see that the moment when I'm invoking the wait method on object monitor, you see that I'm it's you see that I'm basically, that I locked this object monitor, but again, it's not really important for my explanation here. It's just like some code to kind of simulate some processing. But then, at the top of this method, so lines number 12 and 13, I obtained two locks, so a semaphore and a read lock. But they are not detected. So here, underline locked ownable synchronizers, they are not detected. And that creates problems for us when we try to analyze thread dumps. And also, it creates problems for tools, because tools now, they do not have like, information who is owning the lock. Just like quick information about this utility class, so reentrant read-write lock. It's having two inner classes. It's having read lock and write lock. So I will use this class in next example. So just like quick information from API directly. So if thread tries to acquire the read lock, it will be possible if no other thread is already owning the write lock. So if I want to read, it's possible, but if no other thread is owning the write lock. So multiple reads are possible at the same time. But if I try to acquire the write lock, if I want to update something, it will be possible if no other thread is owning a read nor write lock. OK, so now we are ready to follow the next example. So it's a bit tiny, but I will describe so what's the test case here. So in this test case, I want to run two threads. So first thread will obtain the read lock. And after that, the second thread will try to obtain the write lock. So that's the test case. I run this example. I take thread dump, and I check the stack traces. So you can see stack traces here. Again, this block of the code in the middle is just like I simulate that first thread is doing something actually useful. Yeah. So I have this information in my stack trace that I'm holding one lock, so over object monitor. I have information that I invoked the method wait. But do I have any information that I already have read lock? So that information is missing in the thread dump. OK, so let's check the second thread. So second thread is trying to obtain the write lock, and the thread is not able to do that. And we see it in the stack trace. Second thread is trying to obtain the write lock. It's not possible because the lock is owned by some other thread. But which thread? Yeah, we don't know, because it's not being reported in first thread that it owns the lock. So it's kind of known issue, so kind of because maybe it's not even the issue. So I found on internet like one old entry reported for Java 1.5, and the reporter was complaining that ownership over lock is not reported for a couple of utility classes from Java to concurrent, as we saw in those examples as well. The similar situation is when the code is using some third-party libraries for synchronization in the code. So Jackrabbit was using this class. I couldn't find the class nowadays in the Oak, so I guess it's not used anymore. So the issue was closed, and I guess resolution works as designed. So what will be the situation? So when you try to use the tool, you will click on the monitor. You will see, OK, 37 threads sleeping, but tool doesn't know like who owns the lock. So that's the problem. So how to proceed? Yeah, I was looking like a whole day into the thread dump, so 24 hours. And then I figured out, OK, so maybe I understand what's going on. So I was looking at the threads that are blocked on the monitor. And then I saw, OK, so which class is using the Java util concurrent util class? So the first class that is like using my Java util concurrent util class. And so I found it. By the way, this is an example like more recent, so not like from when I started to work with AEM. So here we see that segment node store class in method merge is using the util class from Java util concurrent. And the line number is 201. So what's our next job is, OK, so I need to find the thread that is owning the lock. So it's not reported in thread dump. So how do I do that? Actually, the goal is to find the thread that is not locked on the same monitor, but that is using the same class. So which one? The segment node store. So it should have in its stack trace the same class, the same method, and potentially the line. I hope that line will be greater than 201, because what it will mean that this thread was able to progress further in its processing. So here we have this example. So again, segment node store, method merge, line number 204, and 204 is greater than 201. So I figured, OK, so this thread was able somehow to acquire the lock and moved further. So what was concretely issue here? Problem was on the publish. So someone, client replicated huge package, I think over 1 gigabyte from author to publish. And then this thread is replication receiver thread on the publish. So basically received that huge package and then was trying to persist that package. So this operation took some time. And during that period, all other threads, so read and write threads, get and post requests were blocked. And that was the retail website. So customers couldn't browse catalogs couldn't do shopping. Here I have the screenshot of the source code. So segment node store, method merge. And so basically, as I described, so a lot of threads, so 37 threads were blocked at the line 201 trying to acquire the lock. And there was like only one thread, replication receiver, so that was able to acquire the lock. So it's always good to have the source code, because you can check yourself what's going on. So now I will again try to do the demo. So I will close this log file. I will open the one that I showed just before in presentation. And I will again kind of repeat the steps of this formalized process. So again, I click on the threads view. I order by state. And then again, like a lot of get requests being blocked. Then I go to monitors. So, and then I will choose one monitor, actually one that is matching what I showed in the presentation. So this one, I have information that 37 threads are blocked, but no information who is holding the lock. Then I click on one of the threads, I check the stack trace, and I see the method segment node store.merge. So what I do, I copy this line. I open the thread dump in text editor. So I go Control F, I paste this line of code, and I say find all. So now I have all occurrences of that class and method in thread dump. And you see like many threads blocked on line 201. So my next goal is, OK, let's find the thread that has the same class, same method, and maybe line number greater than 201. I find this thread. So here is line number 204. I scroll up. I see that thread is runnable, and it's a replication receiver thread trying to persist a huge package. OK, so I found my way around. So I was doing that for years. Yeah. So using the tool, using the text editor, finding whatever. But then I was thinking, OK, so I'm going to present you how I was analyzing thread dumps, and I think that's the main point, really, to understand like what's going on in the thread. But I thought, OK, so maybe I could try this kind of formalized approach. Maybe I could try to implement in the tool itself. Actually, I had an idea, OK, I will create my own tool. But then I said, OK, maybe I should just, it's easier just to like modify existing tool, and the one that I was using for years, so my favorite tool. So that's why I did a checkout of the code from GitHub. And I did a few modifications. And actually, I tried to implement the same approach I described to you in the tool itself. So you see here, like, yeah, in the title, MS fork, and it was not the only modification I did in the tool. So I will open the thread. So I have it here. I go to monitors. I find one monitor where I have a lot of threads being blocked, and here is perfect candidate, so 205 threads being blocked. So what was my modification? I analyzed the threads, I applied methodology I described you, and at the bottom I added, I'm not quite sure is it or not, but I added a line, okay, potential candidate that owns the lock is this one. Okay, so similar like before, now I can click on the monitor and jump to another monitor where 37 threads are being blocked. And then at the bottom, I have again information about the candidate that owns the lock. And you see it's again the replication receiver thread. So I did this modification like a few weeks ago while preparing. I didn't really test all scenarios. Yeah, so probably there are many scenarios that I didn't cover in my tool, but yeah, it was fun. It was fun working on that, and yeah, probably I will continue using this modified tool, and why not? I will try to contribute back to the tool, so creating pull request. Okay, so back to the presentation. Long-running threads. So if you are taking thread dumps, so you should try to obtain always more than one thread. Why? Because like most of the tools, they have this feature detecting long-running threads. So you can do it as a first action. So if you have 10 threads, you select them all, and in the tool I was showing to you, it's about doing right click and invoking the action find long-running threads. And then you will get another view where you will see all long-running threads. So they will be like in runnable state, so they have to be in runnable state. And it's really good indication. So if one thread is in runnable state and basically in that state since like a couple of minutes, it's good indication that this thread is probably slowing down the whole system. And then, like from that point, you can, even go deeper. You can maybe increase logging around the packages that you see in that thread, trying to understand what volume of processing is happening there. Maybe this thread is traversing the whole repository or something like that, and this will be useful like when reporting the issue. Okay, quick overview about the tools that I have used. My favorite one, thread dump analyzer. Not favorite because I did some detailed comparative analysis of the features. So again, if I remember correctly, that was just simply the tool that I started to use, and I found my way around, and I continued using it. But my colleagues are using as well IBM thread dump analyzer, and recently I saw like also relying on this online solution, fast thread IO. A couple of links. I strongly advise you to check the first one. I discovered this link basically while creating this slide. Yeah, I thought it would be nice to create some references, and I was like googling around and I found it. And content is really good. I think author started to create the content maybe 2013. I wish I had such information when I started to look at the thread dumps. So really good content, video recordings, explaining in detail different scenarios. And two other links, so one from Adobe knowledge base, and second one from the Oracle website. Okay, so yeah, the whole point of this presentation, I guess, is if you don't feel really comfortable about analyzing performance issues or looking at thread dumps, yeah, you just like need to believe that truth is out there, yeah, or actually in the thread dump. And just like after looking long enough, sub-patterns will start to emerge from thread dump, and yeah, the next time it will be much more easier for you. Thank you very much.